This is problem number 10 from section 310. In this problem it says a light shines from the top of a pole 40 feet high. A ball is dropped from the same height from a point 20 feet away. So this distance here is 20 feet. The ball is dropped from the similar height. How fast is the shadow of the ball moving along the ground? So they want to know how fast is the shadow moving. The ball drops, the shadow is coming toward the ball until obviously the ball hits the ground. The shadow would be right where the ball hits the ground. They would meet. How fast is the shadow of the ball moving along the ground 1/2 second later? Well, the first thing we can do is figure out, I think we should figure out how far it's fallen. And we can do that by simply taking this equation, which is a distance equation, right? So we can say S equals 16 times 0.5 seconds squared. 0.5 squared is a fourth, and a fourth of 16 is 4 feet. So we end up with 4 feet here. So this ball is dropped 4 feet. Now we know that distance. I also think that it's important to know what's the speed of that ball at that spot. So in order to find the speed, we could just simply take this equation, S equals 16t squared, and do the derivative with respect to t, because this is a distance. That would be ds over dt equals, derivative here would be 32t. Plug in our time, that's 0.5, and we end up with 16, this will be feet per second. Now I think it's important to find these two things because we're going to use them later on. They're not asking us for ds over dt, they're asking us for dx over dt. That's what they're saying here, dx over dt. What's happening to the shadow? Well, I think a common mistake, which I've made many times myself, is to start to try to use Pythagorean theorem with this. And when you start to use Pythagorean theorem with this, you start to find different side lengths, and I think it takes you down the wrong path. The thing that you should notice is a little bit of geometry here, is that all the angles are going to be the same. This angle is the same for both triangles. This angle is actually going to be the same as that angle there. So I'm going to label these 1, this would be 2, this is a 90. So all the angles are the same. That means they're similar triangles. And if they're similar triangles, then we know that the ratios of the sides are similar. So what we can do is we can say that this ratio for this side to this side is going to be the same as the height here to the ratio of this side. So here's how we're going to write this. We're going to say that 40 feet over this distance here, and I'm going to label this x. So this side here, which would be 20 plus x, so we're going to say x plus 20, is equal to, so this ratio between these two sides is equal to this original, well, this would be essentially 40 minus s, right? So we'd start at 40 minus this little piece here. Now we already know that that's 4 feet, but let's go ahead and write it. So we'll say 40 minus s over, and then that would be this side, which is just x. Okay, let's go ahead and multiply. We'll do some cross multiplication here and get some stuff together. So we're going to multiply the 40 across. So 40x equals, and we'll multiply this across. You know, I screwed this up. That wasn't right with the similar triangles. It's the right idea, but I need to compare this side with this side, and then this bottom part with this piece here. So I was kind of doing the opposite there. That's why it's not working out how it should. Let's compare this 40 foot. So we'll do this again, 40 feet over this, which is 40 minus s. because we're subtracting out that little bit right there, that distance, which we got from here, is going to equal, and then we'll take and plug in this side, which is x plus 20, over this piece here, which is just x. That's better. So we're going to go ahead and cross multiply here and combine some terms together. So let's multiply this across. It's 40x equals, we're going to take 40 minus s, x plus 20. And then we're going to go ahead and distribute here. So we end up with 40x minus sx minus 20s plus, let's see, 800 equals 40x. We're going to subtract out this 40x from each side. So that's going to cancel, and that's going to be 0 equals negative sx minus 20s plus 800. I'm going to subtract the 800 over, so it's minus 800 equals negative sx minus 20s. And then I'm going to write that up here. So we got negative 800 equals negative sx minus 20s. Factor out I'm going to factor out an s, so we end up with negative 800 equals s negative x minus 20. Let's divide this across. We end up with negative 800 over negative x minus 20 equals s. Now remember, we're trying to figure out dx over dt. So I'm going to actually, let's go ahead and take the derivative now of this. So d over dt. And we'll take the derivative of the whole thing. So this is going to give us ds over dt, when I do the derivative of this piece, is going to equal, now I got to do the derivative here, and I'm going to use the quotient rule. So I've got u, well, I can either use the quotient rule or the chain rule, I suppose. Let's go ahead and use let's use the quotient rule. So u equals negative 800. U prime is going to be 0. V is going to be negative x minus 20. And v prime is negative 1. And this will be dx over dt, because I'm doing it with respect to time. So when I go ahead and do the quotient rule, I take uv, which when I multiply those, cancel. And then I'm going to subtract out negative 800 times this, so I end up with negative, and then when I multiply these two things, that's positive 800 dx over dt. And that's all over v, which is negative x, v squared, negative x minus 20 squared. Okay, now remember, I'm trying to find dx over dt. I know ds over dt, so I'm going to multiply this piece across. So we end up with ds over dt times negative x minus 20 squared equals, this will be just negative 800 dx over dt. So now I just need to divide by negative 800 to this side, and I get dx over dt. I'm going to just flip the side so I have room to write. And this will be ds over dt, negative x minus 20 squared, all over negative 800. And now I just need to plug in ds over dt and x. So ds over dt, we found that at the very beginning it's 16. So we're going to say 16 times, we found x, which is technically s in our case. No, s was the distance dropped. We never found x, actually. So maybe we need to go back and use the Pythagorean theorem to find x. So we're going to have to, we'll have to find x real quick. Let's go ahead and do that. Well, I can say that if this is the same angle, then I can use tangent, essentially, to find this side. So I'm going to say tangent theta for the small triangle. I know that this height is 36. So tangent theta is going to be 36 over x. We found that earlier because s was 4. That means there was a 4 drop, which means this is 36. 40 minus 4. So 36 over x. And then if I do tangent of theta for the large triangle, I end up with tangent theta equals, this will be 40 over x plus 20. But I know that the tangent, the ratio is the same, similar triangles. So I can say that this actually equals this. So I'm going to say 36x, or 36 over x, equals 40 over x plus 20. So when I go and cross multiply here, and I'm going to kind of block this off just a little bit, and I cross multiply, I end up with 36x plus, well, 20 times 36, 720 equals, we end up with 40x there. And then I subtract the 36x over. Right, did I do that right? I did, yes. Subtract the 36 over, and I end up with 720 equals 4x. Divide by 4, I get 180 for x. Okay. So x is 180. I can now plug that in here. So I have 16 times negative 180 minus 20 squared all over negative 800. Now we're going to plug all that in and see if we end up with the correct answer, hopefully. So this is negative 200 squared, which is just 200 times 200, because the negative doesn't matter, times 16, divided by 800, or negative 800, and you get negative 800, and this is feet per second, because it's the dx over dt.